Hello everyone, welcome to the new lesson, and in this particular lesson we are going to answer the second statistical data analysis question. You can see the question is there any statistically significant relationship between order value, cost and refund? So we have our three numeric variables and the question asks to find out whether there is any statistically significant relationship. That means you can see we have calculated our correlation in exploratory data analysis section. Here is the correlation matrix, and we have found cost highly and positively related with order value euro, like the refund. And now we are going to measure whether the relationship is statistically significant. To do so, we have to make the correlation analysis, and let's at first define the hypothesis. In our case, the null hypothesis will be there is no statistically significant relationship between order value, cost and refund, and the alternative hypothesis will be there is a statistically significant relationship between order value, cost and refund. Our significance level will be 0.05 as well. You can see that we have transformed the order value euro and cost variable values as normal distribution. You know that we made a conclusion on order value euro to use the box cox underscore order value, because we have defined this particular variables values extremely follows the normal distribution, and for cost we have defined the yo underscore cost variable values that strongly follows the normal distribution. And for the refund variable we will use actual variable within the actual data final underscore data frame. By combining the three variables we can calculate the relationship. We'll go to ChatGPT and we'll ask ChatGPT, give me a Python code to perform Pearson correlation test. So Pearson correlation test is a statistical measure that perfectly defines the correlations among the variable and defines whether the correlation is statistically significant or not. However, run the command. So you can see at first ChatGPT imported the same library and packages. We do not need it. We have already imported it, and then created the two example variable. We have our variables, so we can ignore it. And here you can see the line of code to calculate the correlation coefficient and the p-value. You can see that from the stats library that dot Pearson r is used. The dot Pearson r is a Python method to calculate Pearson correlation, and within this particular function the variable 1 and variable 2, which is the numeric variables, are loaded. And then you can see that the heading Pearson correlation coefficient, here you can see the correlation coefficient variable which will be calculated and loaded in this particular variable, and which will be shown after this particular heading, and same for the p-value. And as per the p-value we have the same lines of code to automatically find out the result, whether to reject the null hypothesis or we have failed to reject the null hypothesis. So everything is okay. We just need to copy the code from here to here. Go to Jupyter Notebook, paste it here, and we have to make some changes. So at first you have to define our variables. The variable 1 is box underscore order val. The variable 2 is yo underscore cost, and the variable 3 is final underscore df, and within the brackets and quotation mark refund, which is our actual data, right? Okay, so everything is okay, just run the code. Okay, hold on, we got a type error, and you can see the type error is Pearson function takes two positional arguments but three were given. That means you can see this particular line is highlighted. So the error is trying to tell us that the function Pearson R only takes two particular values to calculate the correlation coefficient and p-value once at a time. And you can see that we have given the three particular variables. So that is why the error given. No problem. We'll go to ChatGPT and we'll tell ChatGPT that give me a Python code to perform Pearson correlation test for three numeric data. Now run the code. ChatGPT will automatically provide you the codes to calculate for the combination of three numeric data. You do not need to brainstorm how to do it or at all. Here you can see the lines of code. Everything is similar. For this particular lines of code, you can see that correlation 1, correlation 2, and correlation 3. For the correlation 1, you can see among the three variables, three numeric data, at first the combination of variable 1 and variable 2 is used to see whether there is a significant relationship between variable 1 and variable 2, and then in the correlation 2, the combination of variable 1 and variable 3 is used to see the relationship between these two variables and whether it is significant. And in the correlation 3, the combination of variable 2 and variable 3 is given to see the relationship between these two variables and whether it is statistically significant as per their p-value. And then you can see that the correlation between variable 1, variable 2, and the correlation coefficient will be loaded within the correlation 1 variable for this variable 1 and variable 2 relationship, and which is given here, and the p-value 1 is given. So these two particular lines of code will print out the heading for the correlation coefficient and p-value between variable 1 and variable 2, and the second two blocks of code will print out the correlation coefficient and p-value for the relationship of variable 1 and variable 3, and for the third you can see the for variable 2 and variable 3. And after we will have the decision and conclusion for each combination of variables. For the first block you will see the result of variable 1 and variable 2 relationship, then you will see the result of variable 1 and variable 3, and finally you will see the result for variable 2 and variable 3. However, we will copy the entire code by clicking here copy it, and we will go to Jupyter Notebook. We will replace these particular lines of code, and then we have to make some revisions. At first we will ignore these first blocks of code because we do not need it. First we want to see the relationship between order value and cost. That is why I have used the box cox order value and EO cost. For the second correlation, we want to see the relationship between box cox order value and our actual refund data from final underscore TF, and we will filter out the variables values like this. And for the next one or the third correlation, we'll check the relationship between refund and your cost. So that's all. Now you can change some names, like at first we want to see the relationship between order value and cost. For the second one, you want to see the relationship between order value and refund. For the third one, you want to see the relationship between cost and refund. And you can change the similar thing in the conclusion as well. So for the first one, we have got the relationship between order value and cost. Again, we have to write the order value and cost. Then we got the results for the relationship between order value and refund. So we'll replace the variable 1 and variable 3 by order value and refund. And finally, we'll replace the variable 2 and variable 3 by the cost and refund, because in the final section, we are going to see the relationship between cost and refund. Everything is okay. Just run the command and you can see the magic. So at first, you can see the correlation between order value and cost is 0.99 and the p-value is 0.0. The correlation between order value and refund is 0.95 and the p-value is 0.0. The correlation between cost and refund is 0.95 also, p-value is 0.0. So you can see the correlation between order value and cost is statistically significant as per the p-value. The correlation between order value and refund is also statistically significant as per the p-value, and the correlation between cost and refund is also statistically significant as per the p-value. So this is how you can calculate or test the relationship to check whether the relationship are statistically significant or not by the help of ChatGPT and Python. and the Pearson correlation test analysis. That's all for now. In the next lesson, we are going to answer our last statistical analysis question by conducting regression analysis. Thank you.